All right. Number 31, we've got zeros, -3, 4, and -1. So I'm going to write the corresponding linear factor. So -3 is a 0, x plus 3 would be the linear factor. +4 would be x minus 4, and -1 would be x plus 1. Now, however you want to do this, we want you to multiply this out, write it in standard form. That's the intention of this question, third degree, because we've got 3 different zeros. Just do 2 at a time is the best way you can do these problems. So I'm going to do x minus 4 times x plus 1, just a little FOIL. Draw yourself a box if you want to. You're going to get x squared plus x, then -4 times both, so -4x, -4, combine like terms, minus 3x minus 4. And then I'm just going to bring this guy down. We haven't multiplied yet here. And I'll just go for different colors so we can see it better. This is similar to a FOIL. I call it a triple distributive property. So 3 times all of these terms, or sorry, x times all of these terms, and then 3 times all of these terms. I like to stack these, and you're welcome to do this if you want to, but I'm going to write x times x squared be x cubed, x times -3x is -3x squared, x times -4 is -4x. Now what I'm going to do here, I'm going to multiply everybody by 3, and I'm just going to line up any like terms. So when I do 3 times x squared, I'm just going to line it up under the x squared term. So 3 times -3x would be -9x, and 3 times -4 is -12. So the final answer here, x cubed, these actually cancel out, so we won't have an x squared term, and then it will be minus 13x here, minus 12. So in standard form, there's my answer. Sketch a graph of the polynomial. First thing I want to do, find my leading coefficient, which is x cubed. That is positive and odd, and the end behavior in that situation is down at the beginning and up at the end. Okay, now I have no idea where this crosses the x-axis. So what I want to do here is pull out an x. I'm going to try and factor this. And this quadratic can be factored into factors of -15 that add up to 2. We're going to do an x plus 5 and an x minus 3. This allows me to see my zeros, so 0, -5, and 3. No bouncing, nothing is squared here. So I'm just going to plot those 3 zeros here, -5, 0, and 3. Okay, here's my end behavior. I'm going to draw down at the beginning, up at the end. No multiplicities that are causing bounces or anything, so we're just going to wave right through the x-axis. We know we have to come back down here. We know we have to come back up. So this is just a sketch, and this is an accurate sketch as well as we can of this graph. Make sure you're going through the right zeros. Should go through -5, 0, 3, the end behavior down at the beginning, up at the end. For number 33, we're going to state the zeros, their multiplicities, and the minimum possible degree. Okay, here's a 0, here's a 0, here's a 0. So I have -3, multiplicity, and nothing that's even because we're going through the x-axis. -1, this has to have at least a multiplicity of 2 or 4 or something like that because we have a bounce. Even multiplicity of some kind, I'm going to write 2 here. And then it also goes through 5, probably a multiplicity of 1. Okay, now easiest way I can tell you to determine the minimum degree is the number of different intervals of increasing and decreasing. So I'm just going to trace this real quick. Here I'm increasing, that would be 1. Then I am decreasing, that would be 2. And then I am increasing, that would be 3. And then I'm back to decreasing, that would be 4. So we have 4 different intervals here. So the minimum degree could be more. We know it has to be even because the end behavior is down, down, but the minimum degree here is a 4th degree polynomial. Okay. Quartic function. Okay, quartic function has to be x to the 4th. So the end behavior either needs to be up, up, or down, down. So automatically, I would not look at this graph. This is an odd function. We have one end behavior up and one down, so different directions is odd. So I would immediately not touch that. Okay, 4 real zeros. Here I've got 1, 2, 3, 1, 2, 3. Now, these are bounces here, and it says without multiplicities, so I don't want to pick anything with a bounce. And we have 1, 2, 3, 4 distinct zeros here. So 4 zeros, quartic function, right? Because the end behavior, if I trace my increasing, decreasing, here's increasing, those two intervals, just the same colors I used on the last one. This would be decreasing, this would be decreasing. So I've got 4 different intervals, so that would be x to the 4th. Okay, box plot. Here's your minimum. The first bar is your Q1, the middle bar is your Q2 or your median, those are interchangeable. Third bar is your Q3, and that point on the end is the max. So here's what we're going to do. Q1, I'm just going to match this up with the number 67. Q2 is going to be here to 70. Q3 is going to be 73. Okay, now the IQR is Q3 minus Q1, so we had to identify those first. So this would be 73 minus 67, which would be 6. And your range for the entire box plot would be the maximum value, which is going to be 76, minus the minimum value, which is going to be 54. So 76 minus 54 is going to end up giving us 22. Sorry, my brain stopped. So range 22, IQR 6, Q1 67, Q2 70, and Q3 73. All right, discriminant. B squared minus 4AC. 4AC. All right, so this guy is going to be negative 5 squared, 4 times 3 times 6. Make sure you're careful here when I square this negative. This should become positive 25. And 4 times 3 is 12, times 6 is going to give you 72. Now, it doesn't specifically matter what the number is here. We're really looking for the sign. So this is negative 47. Okay, what this means, if I'm going to do my quad form, we would have plus or minus 5 plus or minus opposite b plus or minus square root this negative 47 over 2 times 3. I'm not asking you to full on solve this, but I'm trying to explain here. So this is the number and type of solution. Because we got a negative here, right, another discriminant, we'd have a negative under the square root in the quad form. So that's going to cause us to have to pull an I out in front of here. So this would end up being 2 imaginary solutions because we're going to have an I in our answer from the negative here. If I had gotten a positive, like if this was just 47, we'd have 2 real solutions because it's not a nice number, but we'd just have the square root of 47. And if this had ended up being 0, we'd have 5 plus or minus 0, so that would be 1 real. So if it's negative, it's 2 imaginary. Positive is 2 real. If you end up with 0 for your discriminant, it's 1 real. 37, you have a couple options. This is the path of a ball and mimicking the height. If you want to know when your ball is going to hit the ground, you want the height to be 0. Okay, you can always use the quadratic formula. If you do so, this would be negative 30 plus or minus square root 30 squared, 4 times negative 4.9 times 3, everybody over 2 times negative 4.9. Now, this is going to be a nasty number. So let's just do this real quick. I'm going to do 30 squared minus, and then I'm just going to put this whole thing in parentheses. 4 times negative 4.9 times 3. Okay. And so we're going to end up with negative 30 plus or minus the square root of this junk, 958.8, over, if you multiply this, you get negative 9.8. Okay, now here's the deal. Oh my gosh, guys, sorry, there's a glare on the screen and I didn't notice. Let me slide this over so you can see the calculator. Okay, if I do negative 30 plus the square root of 958.8, that's going to give me a positive value. I'm going to divide that by that negative 9.8, and that's going to give me a negative number. You cannot have a negative time, so I don't want to select that answer. So I want to do the negative 30 minus the square root of that 958.8, and then I'm going to divide that by negative 9.8. And this should give me 6.22. Oops, sorry, it says round to the nearest tenth, so about 6.2 seconds. The other option, and I want to give this to you so you guys know, is to do this on the calculator. So let me type this quadratic in, negative 4.9, and I know it says t, but I'm just going to use x, and that should not matter. 30x and then 3. Okay, I'm on that negative 10 to 10 window. Okay, now I know you can't see this very well. I'm going to make this go up only, and you don't really need to do this, but just so you can kind of see the path of the graph here. You don't need to do this. Here's the path of the ball. Okay, now this is that tiny number that was negative. We don't want that. I'm hitting the ground when I'm crossing the x-axis. You don't need to display the whole graph to do that, but I'm going to go through how to find this real quick. If you have your graph, I'm going to figure out where this crosses the x-axis. That's called a 0. I'm going to hit second and then the trace button, second calc. We want to find the 0. And so I'm just going to arrow down to number 2 or hit number 2. Should take you back to the graph. Now this little cursor, I call it a spider in my mind, comes up. And you cannot move up and down. You want to use the left and right keys. We're going through the x values. Okay, it says left bound here. Just come somewhere near here but above the x-axis. Hit enter. Remember, I know I'm going down, but I'm moving to the right, so my x value is somewhere below the x-axis. Now, the calculators will pop up these little arrows, and that's saying, hey, look here for where does it cross the x-axis. It will say the word guess here, but you don't need to do that. Just go ahead and hit enter again, and you'll see that's the exact same thing. It's maybe 6.22, a little hard to see on the screen here, but that's exactly the same thing we got using the quadratic formula. So that's just another option. You can use your calculator to find that value as well. Okay, and then we got 2 more on this page. All right, compound inequality. I'm just going to solve these separately. Let's add 2. Negative 2x is greater than negative 6. Now, I'm going to divide by negative 2, so that's going to cause me to flip my sign over. So x is less than 3. I'm going to subtract 7 here. This would give me 11. And dividing by 2, this is 5.5. So this is an OR statement. Sorry guys, I'm going to come over here and draw it over here. So let's say this is 3, this is 4, this is 5, and maybe this is 6. So the 5.5 would be kind of like right in here. This would be a closed circle, greater than or equal to. If I'm greater than or equal to, if my x is on the left, you can just follow the arrow. These values would be greater than 5.5. Less than 3, open circle, because it's strictly less than. Less than goes to the left. Graph should look something like that. Polynomial in standard form, we're just intending for you to multiply this out. So let's go FOIL here. 2x squared minus 8x plus 5x minus 20. 2x squared, let's see, minus 3x minus 20 when I combine like terms. Okay, now I'm just going to leave this for a second. Now I'm subtracting, so I'm just going to leave a little space here. X plus 2 squared, I'm going to do x plus 2 times x plus 2. So, forgive me, x squared plus 2x plus 2x plus 4 if you're doing a FOIL, which would simplify to be x squared plus 4x plus 4. Okay, now I am subtracting that entire thing. So I'm going to go ahead and leave these terms exactly how they are. This is going to become minus, minus, minus. So it's going to be minus x squared minus, 4x and minus 4. Then I'm going to combine my like terms. So 2x squared minus x squared is going to leave me with just, sorry, I'm running out of space, x squared. Negative 3 minus 4 is going to be negative 7x. And negative 20 minus 4 is negative 24. So it should be x squared minus 7x minus 24.